Walkings, Alex, Welch, Max Hu, turn on your video, please. Charlie Lee, Liam Watkins, Alex, Christian, Carson H. Yes, please turn on your video, please. Okay, it's very important, especially for the day of the test and for the quiz, right? You got to turn on your video, otherwise you're not allowed to take the test if you have no video, because nobody knows if you are behind the screen or not, right? That's why you have to have the video available for the, at least for the test, right? So for the dissertation, I mean, okay. Don't be shy. You got to be okay. Now last Thursday, right? We have discussed half of the chapter 1. Chapter 1 is the review of the older material we have learned last semester, right? For so-called the polycalculus, right? So you got to remember how to define domain range, excuse me, domain range, right? And the even function or other function, remember, so on and so forth, right? Now let's continue, okay? Continue with the chapter 1, okay? Let me share the screen with you, okay? What screen here? Let me see. No, this is Microsoft Teams here. Okay. I hope you can see it. Let me just enlarge that so you can see it very clearly. Okay, good. That's the. Now this is what? This is so-called power functions. Okay, power functions. So what does a power function mean, right? This is the form. Okay, fx is equal to fx is equal to x to the power a, right? Power a. Don't worry about that.
Power functions. A function of the form f parenthesis x in parenthesis equals x to the power of a, where a is a constant, is called a power function. We consider several cases. Okay,
enough. Okay, it's called a power function, right? Fx is equal to x to the power a. A is a constant, x is a variable. Okay, you got to remember here, x is a variable, and this number a is a constant, right? X to the power a is a number, a is constant. Okay, now let's look at that. If n is a positive integer, like n equal to 1, 2, 3, 4, right? Now you can look at the picture here. This is you have a bunch of power functions, right? This is n equal to 1, so you have y equal to x, which is a what? Which is a 45-degree line. Remember, y equal to x is a 45-degree line, right? Now, if n equal to 2, you have y equal to what? X squared. So y equal to x squared. This is what? What's the name for this? Remember? It's called what? The parabola, right? The parabola. Now n equal to 3, y equal to x cubed, right? The graph is this. Remember? This is odd function. This is odd function. This is even function. This is odd function again, right? See? Right? We have learned how to sketch y equal to x cubed. Now n equal to 4, y equal to x power 4, right? This is a picture x to the power 4. It's even function, right? See, it's an even function. Why? It's symmetric with respect to what? The y-axis, right? And here, n equal to 5, it has become odd function. It's very similar to cubic power, right? But the graph is slightly different, right? N equal to 5. Tell me, this is an even function or odd function? for fifth power. This function, the last one, is even function or odd function?
An odd.
Alex, what's odd function? Tell me why it's odd function. Alex, what's odd function? Why the function is odd function?
Because it's symmetrical.
Jonathan, it's symmetrical with respect to what? The origin, right? Or you can say that when x is replaced by negative x, the sign has been changed, right? So let me just say that, okay? Let me just use the, okay, for x power fifth, right? See, negative x, right? X replaced by negative x. Look at the power, right? Fifth power, right? It becomes what? This is f negative x, right? F negative x. Fx is power fifth, right? So you replace x by negative x, you will have these, right? Now you simplify. Negative 1 to the power fifth is negative, right? You have negative x to the power fifth, right? Now what's x to the power fifth? Is fx, right? So it becomes what? Negative fx. Right? So you can see that f negative x, your internet connection is unstable. I don't know why. It's quite stable. F negative x equal to negative fx. So this is a what? Odd function, right? Because f negative x is equal to negative fx, right? From the okay, please continue. Yeah, shut off. Okay. Now, from a picture, someone said that the graph is what? It's symmetric with respect to the origin, right? With respect to the origin. This is the origin, right? See, the picture is symmetric with respect to the origin. Even function is symmetric with respect to what? The y-axis, right? So this is odd, even, odd, right? It's easy to see. Look at the power, right? If n is an even number, there is an even function. If n is an odd number, it's a what? Odd function. Easy to remember, right? If n is an odd number, it's odd function. If n is an even number, it's an even function, right? So it's easy to remember, right? So this is called what function? Power function. Understand how to determine if a function is an even function or odd function by looking at f negative x. If f negative x equal to fx, then fx is even function. If f negative x equal to negative fx, then fx may be an odd function, right? From the picture, it's also easy to see, okay? So it's very easy, this section, right? Now let's go on, okay? Let's go on. Now this is the picture for various even function, right? This is x squared, this is x4, this is x power 6, right? Here is x cubed, this is x fifth, right? So you have a bunch of graphs. You can sketch this in the same system, right? You can compare the curves, right? So you have a bunch of curves here. Now a can be what? A can be a what? A can be like 1/2, 1/3, right? A may not be a positive integer, right? Say a equal to 1 over n, where n is a positive integer, right? See, x to the power 1n is equal to x to the nth root, right? We call that the root function, right? The root function, okay? The root function. Now, this is the picture for the root function, okay? Root function. This is what? This is the square root function. This is the cubic root function, right? So let me here. This is the square root function, right? Square root x. This is the cubic root, right? The cubic root of x. So the graph is not signed. See, let's find domain for the first one. What domain for the first one? You cannot take a negative x, right? You cannot have a negative number for a square root, right? So domain for this is what? Let me use interval notation, okay? Is 0 to positive infinity. Right? In domain. Okay? Domain for this function is 0 to positive infinity, right? So this is the picture. See, you cannot have negative side, right? You can have only a positive side. This is the picture for square root function. Okay? If x equal to 1, square root of 1 will be 1, right? So this curve passing through 1, 1. See, 1, 1 is the point, right? So remember, okay, for square root function, the domain is all non-negative numbers, right? You cannot have a negative number, right? So domain for this function is all 0 or positive numbers, right? So the graph is on what? On the right side, no negative side, only on the positive side and 0, right? This is the picture. Okay, you got to remember, this is called what? This is square root function. Power is 1/2. This is the 1/3 power, right? And you can write this as x to the power what? 1/3, right? 1/3. This is easy, right? Power function, if we want to write power function, is x to the power half, right? So all these half is power 1/3, okay? Now look at the domain for this function, for the cube root function. For cube root function, x can take a positive number, 0 negative number, right? So domain for this function is, please write down, okay? It's from negative infinity to positive infinity. Okay, the domain for this function, right? You can see the picture, right? See the picture is what? See, x can go to from negative infinity to positive infinity. And it's an odd function, right? So it's an odd function, see? Right? If x equal to 1, y will be 1, right? So the graph will pass through 1, 1, and this is what? The point will be negative 1, negative 1, right? The point will be negative 1 and negative 1. Okay, so for the cubic root function, right? You pass through 1, 1, and then negative 1, negative 1, right? Because it's an odd function, right? Odd function. See, you got to remember their graphs, right? Yes, the square root function graph, that's the cube root function graph. Okay, this is neither even nor odd, right? Because this function is what? Only on the right side, right? So this function is neither even nor odd for the square root, right? But for the cubic root, it's an odd function. Okay, got to remember what's even function, what's odd function, right? For square root function, it's neither even nor odd. But this function is an odd function. Okay, so we have finished this part. Okay, finished this part. So let me erase that. We don't need this anymore. Okay. No, we don't need this anymore. Let me erase that. Let me clear this. Clear all. Okay, so we don't need this anymore. Okay, now let's go on. A can be what? It can be negative 1, right? Because A can be any real number, right? So it can be negative 1. Now it becomes what? Y equal to 1 over x. Because x to the power negative 1 will be 1 over x, right? Now you got to remember what's the domain for y equal to 1 over x, right? See? Let me see. This is y equal to x to the power negative 1, right? A equal to negative 1. So what's the x to the power negative 1? That's equal to 1 over x, right? Now 1 over x, x is in the denominator, so x cannot be what? 0, right? If x equal to 0, 1 over 0 does not make sense, right? So how to write down domain? Easy to write, right? From negative infinity to what? 0, open interval, right? And the union, right? Union 0 to what? To positive infinity. Right? Or you can say that domain for this function is all real numbers except 0. Look at the picture, right? You cannot have x equal to 0, right? Because x equal to 0, the function is not defined, right? So the curve, this curve cannot touch this vertical line, cannot touch your y-axis, right? Because the function is not defined at x equal to 0. They have only what? Only on the right side, on the left side, but x equal to 0, the function is undefined because domain is all real number except 0, right? Now you can see the picture is this. So this is even function, odd function. Tell me, is it even function? Look at the picture, you can see it very clearly. Even function, odd function.
Odd.
Odd function.
Odd. Why is odd function? Tell me. Why is odd function? Why is this odd function?
Because it's reflected over its origin.
Right. That's the or you can use what? You can use these, right? You can use fx, right, equal to 1 over x, right? This is the function, right? We want to use definition, right? So you have to look at what? F of negative x. Let's see what happens, right? So what's f of negative x? Replace x by negative x, right? So you have what? 1 over negative x, right? You can put a negative sign outside, right? It's same as negative what? 1 over x. So what's 1 over x? Fx, right? It becomes what? Negative of f x. So you can see that f negative x is what? Is negative fx, right? So fx is an odd function, right? Without graphing, we can see from the function, from the formula of the function, we can see right away that this is an odd function, right? Of course, you can sketch it, right? From the sketch, from the graph, it's also easy to see that this function is an odd function. So there are two ways, right? There are two ways of determining that this is an odd function. One is by using the definition, right? By using f negative x equal to negative fx to determine that this is an odd function, or you can sketch it, right? Look at the graph. The function, the graph is symmetric with respect to the origin, right? It reflects with respect to the origin, right? So therefore, this is an odd function. There are two ways, at least, to determine this is an odd function, right? Easy, okay, easy. Let me just clear it. No, let me just clear this because we don't need these. Okay, so this is an odd function again, right? So there are a lot of functions are odd, and there are a lot of functions which are even, right? But of course, there are some functions which are neither even nor odd, right? Like square root function is neither even nor odd, right? Okay, so we have finished. Let's go to this is what? Okay, this is rational function. So what's a rational function mean? It's a ratio of two polynomials. Okay, so px is a polynomial, qx is a polynomial. So this is a rational function. Okay, it's a ratio of two polynomials. The numerator is a polynomial. The denominator is also a polynomial. Okay, you got to remember how to define a rational function. You got to remember, okay? A rational function is a ratio of two polynomials. Now this is what? This is the definition, or this is the example of a rational function, right? Why? Because look at this example. Okay, look at this example. What's the numerator? The numerator is a polynomial of what? Degree what? 4, right? Because the highest power is 4. The numerator, the denominator is a polynomial of degree what? 2, right? The highest power is 2. So this is a polynomial over another polynomial, right? So this is called what? Rational function. Okay, rational function. So there are a lot of examples of rational function, right? Now let's look at domain for this rational function. Okay, for rational function, we should be able to find domain, right? Domain is what? All real numbers except the denominator go to what? Go to 0, right? If the denominator go to 0, then this number should be what? Should be outside domain, right? So you have to find out when this is equal to 0, right? If this equal to 0, this number should be outside domain, right? Because otherwise, these functions does not make sense. We have to solve it. How to solve it? Tell me how to solve this. How to solve x squared minus 4 equal to 0? You can factor, right? How to factor it? refresh your memory from last semester, right? Easy to factor, right? X plus 2, x minus 2, right? Equal to 0. How many roots here? 2 roots, right? 2, negative 2, right? So you have x is equal to negative 2. Right? So 2 answers, 2 or negative 2. So these two numbers should be what? Should be outside domain, right? So therefore, look at that. It's a rational function with domain. The domain, right? Domain. Right? Domain is all real number x except that 2 or negative 2. So x cannot be equal to 2. X cannot be equal to what? Negative 2. Right? Every other number is fine except these two numbers. Right? Except these two numbers. Why? Because for 2 or negative 2, the denominator will go to what? 0, right? The function does not make sense. So therefore, this rational function domain is this, x not equal to 2, x not equal to negative 2. Okay? So for rational function, you should be able to find domain, right? Domain is all real number except the denominator equal to 0, right? So we have finished this part. Okay, we have finished this part. Clear? Okay, easy, right? Easy. Now the graph for this function is this. This is the graph for this. Okay. This is the graph for this rational function. In the future, we'll learn how to sketch this function, right? But not now, okay? In the future, in several weeks, okay, we'll learn how to sketch a rational function, right? But look at this picture. You can see that this vertical line cannot be touched. Why? Because this vertical line is x equal to 2, right? X equal to 2 is outside domain, right? So that's why this vertical line cannot be touched, right? It's called the vertical asymptote. This is same thing, right? This is what? Tell me what's this number here? Negative 2, right? So x equal to negative 2 cannot be touched either. Yes, because negative 2 is outside domain. Now you can see that. Look at the picture. Is it even function or odd function? Look at the picture. Also, it's easier to see from the function formula, right? But you look at the picture, even function or odd function. Carson, is it even function or odd function? You look at the picture. Carson. No, wrong.
Even. It's even.
It's not odd. Even. Why is it even? Tell me. Tell Carson why is it even?
Because you can reflect it over the y-axis.
Right. You can use this as a mirror, right? The left side and right side are mirror images to each other. See, right? This is even function. Also, you can use what? You can use what? You can use the definition, right? This is fx, right? You replace what? X by negative x, right? You can easy to verify that is equal to what? It's equal to fx, right? Because all powers are even powers, right? It's even function. Because so without sketching, right? You can use the function formula, right? To determine that it's an even function. Of course, you can sketch, right? But without sketching, how to determine that? By using definition f negative x equal to fx, right? So therefore, the function is even function, right? So there are two ways of determining whether or not the function is an even function, right, or not, right? So this is fast enough, right? Sketching sometimes is time consuming, especially for a rational function, right? But in the future, we'll learn how to sketch these, okay? But so far, we just look at a picture to see why this is even function, right? Because it's symmetric with respect to the y-axis, okay? So we have finished this, okay? Huh? Clear, okay. Okay, this is even function, right? Now let's go to the next page. Go to the next page, okay? algebraic functions. What does that mean? That means you have square root, right? You have cubic root. It's a combination of these. You have, see, this is a polynomial, right? And then you have what? You have square root of polynomial, right? Look at gx. This is a polynomial. This is x plus square root x, right? So this is not a rational function anymore. Why? Because you have square root x. It's not a polynomial, right? So this is so-called what function? Algebraic function. It's not a rational function, okay? Rational function is a polynomial over another polynomial. This is not polynomial, right? Square root of x is not polynomial, so this is not rational function, okay? This is certain examples, the pictures, okay? The picture, see, this is the picture for x times square root of x plus 3, right? So this is the picture. The domain is what? You look at the function, you can find domain, right? Or how to find domain for this function? Let's find domain. How to find domain for this function? Let's try this domain. How to find it? X is fine. You have to take a look at inside square root, right? So x plus 3 should be what? Cannot be less than 0. Should be what? Should be non-negative, right? So x plus 3 should be larger than or equal to 0, right? Now solve this inequality, right? Minus 3 on either side. So you have what? X larger than or equal to -3, right? So you have found domain easily, or you can use interval notation. So this is the interval notation, right? From -3 to positive infinity, right? Interval notation is this, okay? This. Half closed, right? From -3 to positive infinity. Now look at the picture, right? You have the graph only on what? X larger than or equal to -3, not on the left side, right? So this side, we don't have any picture on this side, right? Only you have the picture on the what? To the right of -3, right? See, this is a picture. Okay. Okay. Now look at B. B is what? It's x squared minus 25 to the fourth root, right? This is a picture. It's an even function, right? It's an even function. Because easy to see that it's an even function, right? This is neither even nor odd. This is also neither even nor odd, right? This is even function. Okay, even function. It's easy to see, right? How to find domain for this function? Fourth root, right? So inside should be what? Inside 25, right? Should be what? Should be non-negative. Same thing, right? Whenever you have cubic root, that's fine. If you have square root or fourth root, inside should be non-negative, right? So x squared minus 25 is non-negative. Now, how to solve this? You can factor, right? You can factor. You have what? You have, remember from last semester, right? We have learned how to solve this, right? You have two answers, right? If you solve equal to 0, you have what? -5 and +5, right? You have two roots for these, right? You have -5 and +5. Now you have what? These two numbers divide this real number line into how many intervals? 3 intervals, right? Left part, middle part, and the right part. You have to decide which interval is the solution to this, right? You pick a number here. Say you pick a 6. You test 6 squared minus 25 is positive, right? So this interval is fine. Similarly, this interval is fine. But if you pick a number inside this, the middle interval, like pick a 0. 0 minus 25 is negative, cannot be larger than 0, right? So this interval is not the solution, right? So domain is what? From -infinity to -5, union from 5 to positive infinity. Look at the picture, right? If from -infinity, this is -5, right? This is -5. Right? So from -infinity to -5, union from 5 to positive infinity. So please remember, okay, how to find domain for a function. Okay, so we have found domain for these, right? So from negative infinity, the union from negative infinity to -5 have closed, right? And from 5 have closed to positive infinity, right? So the domain. Now let's look at hx. Here is fine, right? Because x is what? This is x minus 2 squared is a polynomial. Domain is from negative infinity to positive infinity, right? X 2/3. Okay, x 2/3, right? 2/3. So what does that mean? If you want to write this is what? X squared, then what? Cubic root. Okay, remember how to write. This is a power form, right? This is in the root form, right? So x 2/3 is what? Is x squared to the cubic root, right? They are equivalent, they are sign, right? You can see that for this function, the domain is also from negative infinity to positive, because the cubic root, right? From negative infinity to positive infinity. So look at the picture, right? The domain is from negative infinity to positive infinity, right? X can take any real number you want, right? All right, so this is neither even nor odd. This is even function. This is neither even nor odd. Okay, for this function, the domain is from negative infinity, right, to positive infinity. Domain for this function. Okay, for the function C. Okay, so every function has different domains, right? You got to remember how to find them, right? How to find them. Okay, so we have, right? So you got to learn how to find domain, right? It's very important for calculus, right? Because in the future, domain is one of the most important things. In the very beginning, you have to find domain, right? Because a domain for a function is so basic and so important, right? Without domain, we will not know how to sketch, right? We will not know how to sketch. Okay, so we have found. Okay, now let's go to next page. What's this? Oh, this is our old friend, trigonometry function. We have learned this in Math 1126, right? So let's just refresh your memory. How many trigonometry functions do we have? Let me just how many trig functions do we have? Remember from Math 1126. Angela, can you hear me? Can you hear me, Angela? Yeah. So how many trigonometry functions do we have from Math 1126? Remember? How many of them? You don't know. Okay. Turn off the mic. Unmute it. Unmute your mic.
There's 6 of them.
What?
6.
How many of them? 6. Yes, 6. We have 6 functions, right? What are they? Tell me, what are they?
Sine, cosine, tangent, secant, cotangent, something like that. I don't know. I don't remember the rest.
Go to remember, yeah, easy. Sine, cosine, tangent, cotangent, secant, and what? Cosecant. Right? We have learned this from Math 1126, right? So there are 6 functions, right? Sine function, cosine function, tangent function, cotangent function, secant function, and cosecant function. Right? So the basic functions are sine, cosine, and tangent, right? Cotangent, secant, and cosecant are not so basic, but you got to learn. You got to know, right? You got to know. All these functions will be important for calculus. Okay, so you got to remember these functions are so important, right? So let me share the screen again, okay? Let's continue, okay? Continue. Okay, look at these functions, right? Now this is sine function. Remember the sine curve, right? And this is what? The curve for cosine function, right? Sine 0 is 0, cosine 0 is 1, remember, right? So this is curve for sine function and the cosine function. I don't want to spend much time because we have learned this in math 1126, right? Just refresh your memory. It's impossible for me to go over again because it just what waste our time, right? See, this is the curve for sine function, right? The curve for cosine function. Okay, it's like a what? It's like a wave, right? Like a wave. Okay, so you remember for sine function, the period is 2 pi. For cosine function, the period is also 2 pi. That means after 2 pi, the what? The curve will repeat itself, right? So that means period, right? Now you have no domain for sine is from negative infinity to positive infinity. The domain for cosine is also from negative infinity to positive infinity, right? But the range is what? The range for sine is from negative 1 to 1. This is from negative 1 to 1, right? So you got to remember, okay? This is basic stuff from math 1126, right? The domain for sine cosine function is from negative infinity to positive infinity in domain, okay? Now the range is closed interval from negative 1 to 1, okay? So domain is any real number you want, right? But the range for these two functions are confined between negative 1 and 1, okay? The domain is for x value, the range is for y value, remember, right? So y to fx, right? Y, any function y to fx, okay? Y to fx, right? Fx. What domain is all the possible x value? What's the range is all the possible y values, right? So this is the meaning for domain and range. Got to remember how to determine domain and what's the meaning for range, right? So remember, let me repeat, okay? Please write down. The domain is all the possible x values. The range is all the possible y values. Okay, they're not sine, right? For sine function and cosine function, the domain is all real numbers, right? The range is what? From negative to 1. It's very small, right? From negative to 1. Closed, right? Closed. All right. I don't know why your internet connection is unstable. Let's change. Okay, so that's the what? That's the domain range for sine function, cosine function, right? Everybody should remember, okay? It's easier to remember, right? I don't ask you to go over once again in much detail, right? But you got to remember the basic properties of sine function, so on and so forth, right? Or you can use the what? You can use the absolute value notation, right? Sin x absolute value is less than or equal to 1. Cosine x the absolute value is less than or equal to 1, right? The same as these, right? You can use these notation or you can use absolute value. They are equivalent, right? Now, this is the what? The period, right? Sin x plus 2 pi is sin x, cosine x plus 2 pi is cosine x. It means that the period for sin x is 2 pi. The period for cosine function is also 2 pi, right? So this is easy. Okay, easy. Okay. Okay, now for tan function, it's slightly different, right? Tan function, you have, remember, for tan function is sin x over what? Over cosine x, right? Over cosine. That's definition, right? Okay, sin x over cosine x, the tan function, right? So you can see that what's the domain for tan function, right? You got to understand what domain for tan function, right? Domain is what? All real numbers except that the denominator go to what? Go to 0, right? So you have to solve 1 cosine x is equal to 0, right? 1 cosine x equal to 0. If cosine x equal to 0, then the function does not make sense because cosine x is in the denominator, right? So you have to ask yourself, 1 cosine x equal to 0, right? See, that is 1 what? See, right? That is 1 x equal to this. All right, so x cannot be equal to what? Plus or minus pi half, or plus or minus 3 pi half, so on and so forth, right? Because this value will make what? Cos x equal to 0. Okay, so the domain is what? All real numbers except these numbers, right? The range is easy. The range is from negative infinity to positive. That's range. Okay, now you can sketch this function easily, right? Let's see the sketch for tangent function. See, there's a picture for tangent function. Okay, easy to see because we have learned this, right? Last math for math 1126, right? This is the tangent function curve, right? See, you have a lot of what? Vertical what? Asymptotes, right? X equal to pi half is vertical asymptotes, right? You have a lot of vertical asymptotes here, right? This is vertical asymptote, right? You can write this is what? X equal to pi half, right? This is the vertical asymptote, right? This another one, right? X equal to negative pi half, right? All these values cannot be attained, right? X cannot be equal to pi half. X cannot be equal to negative pi half. This is x cannot be equal to 3 pi half, right? X cannot be equal to negative 3 pi half, right? So all these values are forbidden, right? So therefore we use what? Dotted lines, right? This means these are vertical asymptotes, right? Here you can see that this curve is increasing in this domain, in this part of domain, right? Now inside this interval, the curve is also what? Increasing, right? This is also increasing. Now look at the picture. Tell me this is even function or odd function? Sine function is odd, cosine is even. Let's look at this picture. It's even function or odd function? For 10. What? Look at the picture, it's easy to see. Even function or odd function?
It's
No,
odd.
cannot be even. Odd. Why is odd? Tell me why is odd? Somebody says even. That's wrong. You say it's odd. Tell me why it's odd. Why is this an odd function?
Because it reflects over the origin.
Right. Thank you very much. That's the reason. Right. The picture is symmetric with respect to the origin. Right. This is y. Okay. So remember, okay, sin x is odd function, cosine x is even function, and tan x is odd function again. Right. Okay, so you got to remember when this function is even, when the function is odd, right? Sine function is odd function because the graph is symmetrical with respect to origin. Sine is even function because the graph is symmetrical with respect to y-axis, right? And tan function is odd function because the graph is symmetrical with respect to origin. Okay, so we have learned them, right? We have learned them. Very easy to remember, right? So this is sine, cosine, and tangent. Let's go to the next page. What's this? Oh, this is exponential functions, right? Old plans, right? So remember, okay, this is the definition of the fx is b to x. Okay, they're not sine. Look at that. A few minutes ago, we have discussed these functions. Remember? We have discussed this function. Fx is equal to x to the power a. Now this function is fx equal to b to the power x. Are these sine? Tell me, are these sine? Are these sine? One is fx is equal to x to the power a. The other is fx equal to b to the power x. Are these same functions? What's the name for this function? Remember? We have discussed a few minutes ago. What's the name for this function? We just learned a few minutes ago. You should not have you should not forget this after a few minutes. Right? What's the name for this type of function? The name. What?
Power
Power
function.
function.
What's the name
Power
for this function?
Power function.
No, there's no called odd function. This is not this type of function. What's the name? Remember? We have a special name for these functions, for this type of function, not called odd function.
Power function.
Sine function is also odd. What?
Power function?
I'm sorry, what?
Power function.
God. Power function. Power. P-O-W-E-R. Power, right? Got to remember the name, right? It's power function. Okay, power function. Please write down, okay? Fx equal to x power 8 is called a power function. Like x squared, right? X cubed, x to the power 1/2, x to the power 2/3, right? All these are special case of power functions. Now this is called what? Exponential function. Okay, b to the power x. B is a number, x is a variable, like this. Two to x. 2 is a number, x is a value. This is not power function anymore. This is what? Exponential function. X squared that's power function, right? X squared and 2 to x are totally different. Don't get them confused, okay? X squared is power function, 2 to x is called what? Exponential function. All right, they are not same, okay? They are not same, they're totally different, okay? Power function is x is a variable, and this exponent is a fixed number. Here, the base is a number, x. This x appears in what? In the exponent, right? So they're not same. Don't get confused, okay? Tell me again, x squared is called what function? Power function. 2 to x is called what function? Exponential function. All right, so here, see, the base b is a positive constant, right? So here, base b is positive, okay? We don't use b equal to 0, b equal to negative. The base b is always positive, okay? Positive. So that's the definition of the exponential function, all right? You got to remember how to define it, okay? Now look at the picture. We have two exponential, okay? That's the picture. You got to keep in mind, okay? This is what? 2 to x. 2 is a positive number, right? This is 0.5. 0.5 is 1/2, right? 0.5 to the power x. So this is what? Increasing function. This is what? Decreasing function, right? This is neither even nor odd, right? This function is neither even nor odd. This function is neither even nor odd, right? But this function is increasing function. This function is what? Decreasing function, depending on base, right? So remember, okay, for b is larger than 1, this is increasing. So b is less than 1. This is what? Decreasing, right? So let me. Okay, so please write down, okay, y equal to b2x, right? This is exponential function. If b larger than 1, okay, the function is what? Increasing, right? If b is less than 1, the function is what? Decreasing. So please write down, okay? We have learned this before, right? I just want to refresh your memory. Of course, here b is always positive, okay? We have b is always positive, okay? So if b is larger than 1, the graph is what? Is increasing. If b is less than 1, the graph is decreasing, okay? Here b is 2, right? Here b is 1/2, is less than 0.5 is less than 1, right? So the graph is decreasing. Okay, now what's beautiful for any b, right? If x equal to 0, this is always equal to what? Right? So if x equal to 0, always equal to 1, right? X equal to 0, always equal to 1, right? Because b to the power 0 is always equal to 1, right? So the graph passes through 0, 1. The graph passes through 0, 1, right? So x equal to 0 is y always equal to 1, okay? So this is so-called what? Exponential function. Okay, everybody should remember how to sketch, right? So remember, okay, B is larger than 1, the graph is increasing. B less than 1, the graph is what? Decreasing, right? Now, look at domain for these two functions. What domain for these two functions? Easy to see from the picture. What domain? Remember, domain is all the possible x values. So look at these two pictures. What domain for exponential function? The domain is what? Let me write
All real
down. D
numbers.
means domain, okay? D means domain. All real numbers. So how to use interval notation? From negative infinity to what?
Infinity.
To positive infinity, right? The domain. What's the range? R means range, okay? R means range. Range, look at the picture. All positive numbers, right? You cannot take a negative number. You cannot take y equal to 0, right? Because this is called what? Horizontal asymptote, right? So please write down. The range is open interval from 0 to positive infinity. Okay, so please write down the domain for exponential function, right? It's always from negative infinity to positive infinity. The range is all positive number, right? The y value, right, cannot have a negative number, cannot be equal to 0. And this is called what? Horizontal asymptote. Horizontal asymptote. You have two. You have horizontal asymptote for this. You have a horizontal asymptote for this, right? So y equal to 0 is a horizontal asymptote, right? So therefore, y cannot be equal to 0, right? The y value for exponential function is always positive number, right? Positive. Okay, got to remember how to find domain, how to find range. Remember, these are what? Neither even nor what? Nor, right? Neither even nor. Look at the picture, easy to see, right? It's neither even nor all. Okay. So we have finished this part. Very good. Let's go to the next page. What's that? Oh, log function. These are also old, right? Also old. How to define the log function? Is inverse function to exponential function, right? This is, so let me write down, okay, how to define the log function, right? How to define the log function. So this is the definition, okay? The definition. So please refresh your memory, right? So y equal to log b is the base, right? X. So what does that mean? What's y equal to log bx mean, right? This is if only if x equal to what? Equal to b to power y. Okay, that of course here b should be what? Here we have to require that b is positive and b not, because b equal to 1 does not make a lot of sense, right? So we have to require these, okay? We have to require that b is a positive number, but b not equal to 1, all right? So this is the definition for log function. Y equal to log bx if only if x equal to b to power y. Okay, so log function and exponential function are so-called what? Inverse function to each other, right? Inverse function to each other. So you got to remember how to define the log function, right? So the base b for log function is that b is positive, but b not equal to 1, right? And this is the definition of log function. So remember, okay, y equal to log bx if only if x equal to b to power y. Okay. So remember, okay, log functions and the exponential functions are so-called what? Inverse function to what? To each other. Okay. Now this is the picture for log function. Okay. This is base 2, right? This is base 3. This is base 5. This is base 10, right? You can see that. Okay. Easy to see, right? Easy to see. Okay. Now let me look at the picture. Let me find domain for this log function. Okay, because it's so important to know domain and range. What domain for log function? And what's range for log function. Look at the picture. The domain is for what? For all positive numbers, right? Look at the picture, right? Open interval, okay? The range is from negative infinity to positive infinity, okay? So please write down, okay? This is for log function. Okay, so for log function, the domain is all positive numbers, right? Positive real number. And the range is from negative infinity to positive infinity. So please write down, okay? This is the domain, the range for log function. The graph is this. Okay, the graph. All right, so you got to remember how to find domain and the range for log functions. Okay, so this is the graph. So the domain is from what? 0 to positive infinity, all positive real numbers, right? The range is from negative infinity to positive infinity. Okay, you need to remember, right? You need to remember. Now let's look at the next page. Oh, no more exercises. Okay, exercises. So we don't want to do that. Okay. Now this is easy. I don't want to go over that. It's new functions from old functions, right? This is so straightforward. So I don't want to spend time on this because you have just, let's look at what that means. Transform of functions, right? You hear how to shift. We have learned this so many times, right? How to shift up, how to shift down, how to shift to the left, how to shift to what? To the right, right? This is equal to fx, right? Fx plus c, you shift up. Fx minus c, you shift down, c units, right? Fx minus c, you shift to the right, c units. Fx plus c, you shift to the left, c units, right? This is so easy, right? You have to know how to translate, how to shift along, right? You have 4 directions, right? Up, down, left, right, right? So that's the meaning, right? That's the meaning. So it's straightforward. Okay, this section is so easy. Now you have to know how to shift, right? This is shift to C units up. This is C units down. This is C units to the right. This is C units to the left, right? So this is C positive, right? So you got to remember. Okay, we don't have to worry about this video. Okay, this is so easy. Okay, so easy. So this section is easy because this is very straightforward, right? So you got to remember how to shift, right? See, this is what? This is the basic function, right? Square root of x is the basic function. You have to what? This is shift down 2 units. This is shift what? To the right 2 units. This is negative x. You what? Positive become negative, right? This is 2 times square root of x. You what? Stretching, right? This is what? X become negative x. You shift to the negative part, right? That's easy. It's easy. So I don't want to see this is the picture for how to shift, right? How to shift. Okay, so this section is easy. Now you have to what? This is, you have to complete square, right? You want to sketch so-called what? The parabola, right? The parabola. This is very straightforward, right? So I don't want to spend a lot of time on this part, okay? This part. This is just shift. Now combinations of functions, right? You have to know how to what? How to add. This is add, right? How to subtract, that's so easy, right? And how to multiply and how to divide. This is 4, remember we have 4 operations, right? Addition, subtraction, multiplication, and division, right? This is easy. It's easy. Now, here, you have to what? You have to know this is the so-called the composition. Now, this is, I just want to remind you how to do composition, right? How to do composition here. How to do composition here. See, you have 2 functions, right? Y equal to f of u, right? Y is a function of u. Now u is what? U is another function of what? G of x. Right? You have 2 functions. Y is a function of u, and u is a function of x. Now you can what? You can combine them into one single function, right? We call it what? called composition. Okay, composition. How to compose them, right? So it's easy. Look at these. Y equal to F. What's U? U is G of X, right? So we replace U by G of X. Okay, so we have done the composition of F and G, right? So see, this is the composition. See? Right? Y equal to F U, U is G of X, right? So if you combine them, it's Y equal to F of what? Gx. Okay, they call it composition. Composition is not same as multiplication. They are not same. Okay, it's just another way of combining two functions, right? F and G, right? They call it composition. Okay, so remember, Y equal to Fu, U equal to G of X, right? Now you replace U by Gx, you get Y equal to F Gx. All right. So now let's do some examples here. Okay. Y equal to square root U, and U equal to X squared plus 1. Okay, how to combine them? Y is the square root function, square root U, right? U is a polynomial, right? It's a quadratic polynomial X squared plus 1. How to combine them? Easy. Replace U by what? By this, right? So see here. Right? Y to Fu, F of Gx. That's F. Gx is X squared plus 1. This is Gx, right? X squared plus 1, right? Now combine them. Replace U by X squared plus 1. You have these, right? Final answer is Y equal to square root X squared plus 1, right? So this can be what? Can be decomposed into what? Square root function and a quadratic polynomial, right? This is called composition of two functions, okay? The composition and the multiplication are not same. They are totally different, okay? So this is called the composition of two functions, okay? Now how to compose it, right? This is a notation for composite of F and F with G, okay? We have learned this, right? We have learned this, okay? Now let's do this. Let's one more time over, right? Let's finish these, okay? Let's finish these. Let's look at this example, okay? This example, okay? Fx is X squared, Gx is X minus 3. How to compose it? F, G, and Gf. They're not same, right? So what does that mean? F Gx is F of what? Gx. And Gfx is G of Fx. Okay, that's different. This is the definition, right? F Gx is F of Gx, and Gfx is Gfx. That's definition, right? Now F, what's Gx? Gx is X minus 3, so Fx minus 3. Now you have to what? You have in this formula, you have to replace X by X minus 3, right? In this formula, right? So whenever you see X, you replace by X minus 3. So this will be X minus 3 squared. This is for these, okay? Now, what's the second one? Second one is G of Fx. Fx is what? X squared. So you have, in this formula, you have to replace X by X squared, right? So X squared minus 3. So this is for this one. Are they same? They are not same, right? X minus 3 squared is not equal to X squared minus 3, right? So remember, these are not same, okay? So in general, these are not same, okay? In general, these are not same, okay? So F composed with G and G composed with F are not same in general, right? No, see here, right? Right? In general, F, G, and GF are not same, okay? So you got to remember how to find the composite of two functions, F, G, and GF, right? In general, they are not same. Got to remember that, okay? Okay, time is over. So it's 7:37. We should stop at 7:30. Okay, so let's, okay. Any questions so far? We have finished a lot of things, right? Right, but there's nothing new here. We just reviewed all the stuff, right? We have discussed a lot of functions, right? And sorry, what? We have discussed a lot of functions, right? And we also learned how to do some, how to shift, right? How to shift. And we also learned how to do some basic operation, especially composite of two functions, right? So remember, fg and then gf are not signed, right? F plus g is always equal to g plus f. F times g is not equal, always equal to f, is always equal to g times f, right? But f composed with g and g composed with f are not signed in general, right? In general. Okay. So that's the meaning for composite of two functions. Okay. This is something you got to remember. F plus g and g plus f is always same, right? F times g and g times f is always same. But f composed with g and g composed with f in general are distinct. Okay, are distinct. Any questions so far? If you don't, you may leave. If you have